It seems like nobody can escape the rising costs of AI, which doesn't really sound very good, but I think it's pretty great because the whole industry seems like right now focused on optimizing AI costs, and we can learn a lot from those approaches no matter if you own a company and want to optimize your team or you would like to max your subscription. And it is also for the first time ever that I'm thinking, okay, how can I maximize the usage of my subscription? Mainly because of Fable and because of the token heavy features that Claude has been introducing, such as dynamic workflows. And the first pattern that we're going to look at right now comes from Anthropic. It's something that's pretty popular. It is the idea of using a cheaper model like Sonnet 5 as an executor and then Fable 5, the smarter model, as an advisor. Although to be honest, I'm not a big fan of this pattern in particular because the less smart model like Sonnet 5 has to decide when to ask the smarter model for advice. I think the other way around is much better, and this is something that Anthropic also proposes. We have the smarter model as an orchestrator, and then we fan out to workers, which don't need that much intelligence to complete tasks that are especially token heavy. And we can see that the Fable 5 orchestrator achieves 96 of the Fable 5 performance at 46% of the price. And they also have created this cookbook where it's explained in more detail how they have exactly run this experiment. But basically we have a coordinator, and the test that they have been running is pretty small. They have just run a web search, and in this web search they had to answer some particular questions. And instead of the coordinator doing the web searches and parsing the internet and the web pages, which you can imagine is pretty token heavy, they just have started sub agents for every search, and then they report back to the coordinator. Now, how can you achieve something like that yourself? I think you can start experimenting with editing your Claude MD or Agents MD files, and then giving tips to the agent for which tasks, what sub-agents to span. For example, for computer use, you can tell it use Haiku 4.5. And we know that Haiku 4.5 is pretty good at computer use. It's also the cheapest model from Anthropic. And you can also do the same thing if you are in the OpenAI ecosystem. For repo exploration or web search, use Opus 4.5. We know that Sonnet 5, although it should be a cheap model, it's actually not very cheap. So that's why I don't recommend using it. And for implementation, you could say use Opus 4.8. And then when it came to implementation, I can see that Fable has spanned Opus 4.8 as sub-agents to complete the implementation. And then the sub-agent reports back the result to Fable. And then Fable judges the result if it's okay or if something else needs to be done as well. For example, I have here one dynamic workflow that is being implemented by Claude Code. We can see that the workflow has 4 different stages. We have the implement stage, which uses Opus as a workhorse. And then we have the advice stage, which uses Fable as spec compliant reviewer. And you can see the phases here that are running right now. Implement phase is running, and then Opus 4.8 is implementing it. And this is how we can save a lot of tokens that we can save on Fable usage, because you know it is very limited right now. And by the way, you could also use Codex as a workhorse for implementation. You just have to tell Claude to delegate any implementation to Codex and to use the Codex CLI. And another great report actually came from Databricks, which is pretty surprising, but it resurfaces a lot of the intuition that people in the industry were having about how to optimize token usage. And it's very interesting also because it's a super rich company and they are already thinking about optimizing token usage. Essentially, they have created a benchmark, and then they have run different models and different harnesses against this benchmark, and here's the result in this image that we can see. Higher is better on the y-axis, and left is better on the x-axis, which is about cost, and the y-axis is about intelligence. And I can give you an example here. Opus 4.8 in the PyCoding agent performs better than Opus 4.8 in Claude Code, and it's also cheaper. So it means the coding harness made Opus smarter and cheaper. We also have GLM 5.2, which is an open source model that achieves incredible level of performance for a fraction of the price of Opus 4.8. And the conclusion that we have from this benchmarking is that open models and GLM 5.2 in particular are now able to handle even the highest level of task difficulty. Then something really important as well, the token price of a model is a poor indicator of the actual cost incurred on an end-to-end task, which means that the model can be very cheap, but if it burns a lot of tokens to solve the task, then the overall cost of the task is pretty high. And this is the case with Sonnet 5. And as Databricks says, larger models can be far more token efficient and have lower overall cost. And the most important part of this analysis is that the harness a model is called from dramatically impacts cost and quality. In many cases, simple harnesses like Pi perform best on our workloads. And they also say model cluster into rough capability tiers, and you don't need the highest intelligence tier for some simpler tasks, for example, for config changes. Common operational tasks like flipping a flag or updating configs don't require extremely intelligent models. However, in the past, our default models were always the most expensive ones. Based on this analysis, we determined we should push more work to the Haiku and GPT 5.4 mini class of models. And I think this is something that the whole industry will start going towards. This would be especially a big team in 2027 and probably the end of 2026. Open models are here for coding, GLM 5.2. Harnesses have a major impact on efficiency. We can see the Pi harness, it's 1.5 to 2 times usually cheaper on every single model. Pi sends about 3 times less context per turn, which means that the Pi harness manages the context much better than Codex or Claude code. And how this could happen, for example, is that if the model sends a request, grab out provider, a not very efficient harness would just return every matching line. But what Pi does, or what context optimization within a harness looks like, is that we do search out provider and then we cap the results to 20. So what we can learn from Databricks is choose your harness correctly, remove bloat from your harness as much as you can, which reminds me of Matt Pocock. He wrote this great article on his website aihero.dev, and essentially what he did is to implement a proxy and to observe every single request that Claude Code sends to Anthropic, and then identify the culprits that are polluting his context, and then simply remove this bloat configuration for features that he doesn't use but Claude Code keeps in the context. And I think what would emerge by the end of the year or next year is the creation of harnesses that are tracking your usage and that are telling you if you're using the right model, the right intelligence for the task, or you can actually use less intelligent model to complete your task. Basically, I think we'll see the birth of proxies that are giving more insights in how we use the harnesses and how we can better improve them. And if you look at the broader industry, we can see also other players taking steps towards being way more efficient. For example, the latest launch of Grok 4.5, they were not targeting to be the latest frontier intelligence model, but they were targeting to be the most efficient. They were just trying to make the fastest, most cost-efficient model that is just good enough to complete the tasks. And I think they won this category, and this category is getting so much bigger because we don't need more smarter coding monkeys. Those models are coding monkeys. We just need coding monkeys that are good enough, and we need one frontier coordinator that can actually manage them. I think Grok 4.5 is just a really good, cheap coding monkey. And this is something that a lot of companies would copy. We can also see DeepSeek creating their own chips, OpenAI trying to run extremely efficient inference on Cerebras. Basically, everyone is trying to figure out, okay, how can we make this cheaper, faster, and better? I think this is absolutely great news. And the takeaway from this video is if you want to decrease the cost of your token usage, delegate tasks that are lower intelligence but require a lot of tokens to cheaper models. Think about your harness as well. Pi coding harness seems to be really good for saving costs. And try to keep things simple and not necessarily use the latest and greatest stuff from Anthropic, such as dynamic workflows, because they burn so much tokens.